Wow, think about your day. What did you use that needed power? Your phone, a remote control, maybe a flashlight, or even a car? So many things we use every single day rely on these little energy packs we call batteries. They are like tiny powerhouses that we carry around in our pockets or put inside our favorite gadgets. It's pretty amazing, isn't it? These small cylinders or flat packs hold the secret to making our electronics go, go, go. Without them, our world would be a very different and much quieter place. Imagine that. Consider this. No portable music players, no quick photos with your digital camera, no video games on the go. Even life-saving medical devices like pacemakers often rely on battery technology. They give us freedom. Freedom to move, freedom to communicate, and freedom to explore, all without being tied to a wall socket. That's a lot of responsibility for such a small object. They are the unsung heroes of our modern portable world, working silently to keep us connected and entertained. Pretty neat, huh? Alright, let's talk about the big idea behind batteries. The main job of a battery is to change one kind of energy into another. It takes chemical energy, which is stored in special materials inside the battery, and turns it into electrical energy. That's the spark that powers your devices. Think of it like this. Chemical energy is like the energy stored in the food you eat. Your body then converts that food energy into energy you can use to run and play. A battery does something similar, but for electronics, it's a fundamental energy conversion. Imagine a coiled spring, wound up tight. That spring has potential energy, right? It's just waiting to be released. The chemicals inside a battery are kind of like that wound-up spring. They have chemical potential energy. When you put the battery into a device and turn it on, you're essentially letting that spring uncoil. As the chemicals react, they release their stored energy. But instead of making something bounce, this energy pushes tiny particles called electrons. And moving electrons, my friends, that's what we call electricity. It's an amazing transformation from still chemicals to flowing power. A battery is cleverly designed to control this chemical reaction. It doesn't let it happen all at once like a big explosion. It controls the reaction, making it happen slowly and steadily, so we get a nice, consistent flow of electrical energy. Every battery, no matter how big or small, has a few key parts working together. Think of them as the superstars of the battery team. First up, we have the anode. This is usually the negative side of the battery. The anode is made of a material that has a special job. It wants to give away electrons. It's like a generous friend who always has something to share. These electrons are the tiny particles that will eventually flow out of the battery and power your device. So, the anode is where the action starts. Next on our superstar team is the cathode, you guessed it. This is usually the positive side of the battery. The cathode is made of a different material, and its job is the opposite of the anodes. The cathode really wants to accept electrons. It's like an eager catcher waiting for a ball. So, we have the anode wanting to give electrons, and the cathode wanting to take them. This difference in desire, this electron pressure, is what we call voltage. It's the push that gets things moving. They need a special medium to help them do their jobs, and that's where the electrolyte comes in. The electrolyte is a chemical substance, often a liquid or a gel, that sits between the anode and the cathode. Section 4. The electron dance. How the magic really happens. So we have our anode, cathode, electrolyte, and separator. How do they work together to create electricity? It all comes down to special chemical reactions called redox reactions. That sounds complicated, but it just means reduction and oxidation happening together. At the anode, the material undergoes oxidation. This means it loses electrons. Think of oil. Oxidation is loss of electrons. These electrons then build up at the anode, eager to go somewhere. They are full of energy. These electrons can't go through the electrolyte to get to the cathode. Remember the separator and the electrolyte's rules? So when you connect a battery to a device like a light bulb or a motor, you create an external path. This path is usually a wire. The electrons, seeing this open road, zoom out of the anode, through the wire in your device, and do their work, lighting the bulb or spinning the motor. Then they travel to the cathode, which happily accepts them. At the cathode, the material undergoes reduction. Section 5. Battery Showdown, Alkaline versus Lithium-Ion. Not all batteries are created equal. There are many different types, each with its own chemistry and best uses. Let's look at two common types: alkaline batteries and lithium-ion batteries. You've probably used alkaline batteries many times. They are the common AA, AAA, C, D, and 9-volt batteries you find in supermarkets. They are great for things that don't need a huge amount of power, like your TV remote, wall clocks, or some toys. They are relatively inexpensive and easy to find everywhere. Alkaline batteries typically use zinc metal as the anode and manganese dioxide as the cathode. The electrolyte is an alkaline substance, like potassium hydroxide, hence the name alkaline. They provide a steady voltage for a good amount of time. However, once their chemical reactants are used up, that's usually it. They are generally not designed to be recharged. They have a decent energy density, meaning how much energy they can store for their size, but other types can pack more punch. They are reliable workhorses for many everyday applications. Now let's talk about the powerhouse of modern portable electronics: lithium-ion batteries. Section 6. Use it and lose it, or power up again. Have you ever wondered why some batteries can be recharged, while others are just thrown away, responsibly of course, after they die? It all comes down to the type of chemical reactions happening inside. Batteries can be broadly classified into two main types: primary batteries, which are disposable, and secondary batteries, which are rechargeable. Primary batteries are designed for a single use. Their chemical reactions are generally not easily reversible. Once the chemicals inside have reacted and produced all the electricity they can, the battery is spent. Think of a primary battery like a piece of firewood. Once you burn it, it turns into ash, and you can't easily turn that ash back into wood. Alkaline batteries, zinc-carbon batteries, the older, cheaper ones, and those tiny coin or button cells used in watches are usually primary batteries. They are convenient for certain applications because they can hold their charge for a long time when not in use, and are often less expensive up front. Section 7. The amazing battery powering our world. So there you have it. The battery, a small, often overlooked device that is actually a marvel of chemical engineering. From the simple idea of converting stored chemical energy into useful electrical energy, scientists and engineers have developed these incredible power packs. We've seen how the anode, cathode, electrolyte, and separator all work together in a precise dance of electrons and ions. It's a tiny, controlled chemical reaction happening right in your hand or in your pocket. It's truly amazing when you stop and think about the science involved. The impact of battery technology on our society has been absolutely huge. Think about it. Batteries have given us portability. They've untethered us from the wall socket, allowing us to communicate from almost anywhere with our mobile phones, work on our laptops in a park, or listen to music while jogging. They power life-saving medical implants and make exploration possible in remote places. And now, with the rise of electric vehicles and renewable energy sources like solar and wind, batteries are playing a crucial role in storing clean energy and helping us build a more sustainable future. And the story of the battery is far from over. Scientists all over the world are working hard to make batteries even better. They are searching for new materials that can store more energy, last longer, charge faster, and be safer and more environmentally friendly. Imagine batteries that could power your phone for a week, or charge your electric car in minutes, or batteries made from abundant, sustainable materials. The quest for the perfect battery continues, pushing the boundaries of chemistry, materials science, and engineering. If you enjoyed this video, hit like, share it with your friends, and leave a comment below for more informative content.